Kence, good to have you here at Manufacturing Happy Hour. And I imagine your ears may have been burning lately because I've been mentioning your name a lot in a lot of conversations around AI agents. So good to have you here to hear it from the source in today's episode, if you will.
Yeah, thanks for having me.
Well, my first question, in the spirit of Manufacturing Happy Hour, as if we're having this conversation over a beverage, let's say you're at a bar out there in the Bay Area or you're at the trade show Happy Hour and someone asks you, Kence, what in the world is an AI agent? How do you describe that to them in the context of manufacturing, in the context of like an over a drink scenario, candid and to the point?
Yeah, absolutely. An AI agent is it's like a virtual operator practices accomplishing some specific tasks. You're an operator of a injection molding machine. It's not really that much different than any other task that we practice. Whether it's practicing a football play, a chess strategy, practicing, almost at cooking, some sort of recipe. There's this aspect of trying, getting feedback, and practicing. That's what operators do. They spend decades in some cases mastering what happens in different situations as play the game, and that's true for a lot of things. And so an agent is something that is going to master a task, very specific task. Now remember, expertise is task specific. So Chris, you could be a great driver but a terrible chess player, and I could be a great basketball player but a terrible musician because expertise is task specific. So we're not talking about what people call artificial general intelligence. You don't have to do everything in a factory. In fact, no one's going to hire me to work in a steel mill, even though I'm pretty intelligent. So are you. It's actually what we practice and what we master. So an agent is taking on a specific task, getting feedback, and proving that they can perform well, pursuing a goal for that specific task.
And we're going to take a deeper dive into this about halfway through the conversation. I want to ask you about your background a little bit, but I think the first question I need to ask before we get there is, I hear about AI agents a lot these days, and I feel like a lot of folks are, but I could be wrong. We were chatting before the interview. I was given a presentation recently to a room full of manufacturing executives, and maybe it was the fact that we were ordering food at the time and things like that, and people were a little bit distracted. But when I was asking, it's like, hey, who's been hearing a lot about AI agents lately? I didn't see as many hands go up as I thought. So my question is, I hear about AI agents a lot in the context of like Salesforce, for
Right.
example, or the context of someone that's going to help you with a digital task online, if you will.
Yeah.
Can you frame an AI agent real quick in the context of manufacturing, like physical manufacturing?
Yeah, that's actually a really good question. And I have an idea about that I'll test out with you about why people in manufacturing are thinking about agents differently than people at large, right? So right now, in the general conversation, in society, almost everyone's talking about agents. They talked about agents at the World Economic Forum. They talked about agents at the White House. These pieces of software that can do something. And from that perspective, people are really excited for two reasons. One is people are thinking, wow, there's AI that can finally do something. And I say that kind of tongue in cheek, but not really, because previous waves of AI and ML were about, okay, your life is going to change if you can analyze this, analyze data. Well, kind of. I mean, if you can predict this, it's going to change everything. Well, not really. I mean, in every, certainly enterprise and industrial situation, the thing that moves the needle is decisions, great decisions. And so if you're predicting something, analyzing something, it's only to serve the purpose of making a great decision. So some people are very excited because they're like, oh man, there's AI that can actually make decisions or actually do things. The second thing that captured the general imagination is, the generative AI, the large language model. This idea that there's this AI that I can talk to, like I can ask it a question like in natural language, and it will draw a picture for me, write a paragraph. And so it really sparked people's imaginations like, ooh, it's AI that I can actually interact with. I don't have to like learn some programming language or something to make it do something, and then it can do something. Now here's the other side of the coin. If you're in engineering, like I studied mechanical engineering, if you're in engineering, the thought that there's a piece of software that can make a real decision is not novel. I mean, the PID controller was invented in 1912. So we've been automating things as engineers for a very, very, very long time. So what's interesting to me about that is, okay, now there's certain enabling technologies that allow AI to maybe make more human-like decisions or more nuanced decisions or more decisions in manufacturing that previously only humans beings could make. But no engineer is going to, jump out of their chair and go, "Oh, there's an AI that can actually do, make a decision." They're like, "Yeah, that's what a control system is." So there's this kind of two ways to think about it.
I like the way you phrase that. I also like your example of going back to a PID controller where we've had instrumentation and controls that have helped manufacturers make decisions for a long time. Uh, the way I want to maybe frame this up in the context of an application is if you could describe how an AI agent is different from what I think manufacturers have recently thought of when it comes to AI in the context of machine learning, right? Looking for quality defects, if you
Ah,
will.
yes,
Seeing that, I think that's an example manufacturers are familiar with. Hey, there's a camera, it's looking for defects, it's been given some parameters to help pick up those defects and learn on the way. Machine learning. How does an AI agent take this to a different level
beautiful.
relative to what we've thought of as kind of a default AI machine learning example for the past few years?
Beautiful, Chris. It's the difference between perception and action. So most of what people are doing with machine learning in factories, and it's very important work, is perception. Can I identify a defect? That's visual perception. I've seen auditory perception. Can I hear? Or even prediction. Is prediction perception? Yeah, I think so. When a farmer, kind of does this and feels the wind direction and looks at the shape of the clouds and the color of the clouds and the color of the sky and says it's about to rain, that's a prediction, but it's a perception. They're combining all this information into a perception about whether it's going to rain. So predictive quality, all those kinds of things. That's perception. Action is what to do. And so, for example, I worked with someone who is at a large CPG company, and he had developed some perceptive models that could detect defects in these consumer product goods. And the very next question, he actually deployed many, many of these, like 100 of these, and within their company. And the very next thing people started saying was, well, if I can detect that the defect is happening, I need to do something about it. So the very next thing people started asking about is what agents do. So what am I going to do about it? And so if you look at reference architecture I have, which we may talk about later in the podcast, uh, for intelligent agents, there should be perception, but there also has to be action. An agent must be able to take action.
So action is what you're saying is the big differentiator here. Am
Yes,
I hearing that correctly?
I
Where
believe
in the
so.
past, you would be able to get all that information from a machine learning algorithm. You'd be able to say, okay, here were the 3 defects out of the 1,000 parts that were just produced. Now, with an AI agent, it is going to give you some sort of action to take in response to that.
Yes. How do I change the set points to eliminate that defect? How do I change the set points to prevent that defect? What actions do I need to take to change the situation?
I love it. I had a feeling this might be a little bit of an extended intro today, so this is good. We're gonna look under the hood here in a second, but you have a very long, fascinating career in the manufacturing and startup world and beyond. So not everything you've done has been in manufacturing, but you got your start in the manufacturing world. You were telling me. Give us where Kence's career got started and how things have led to today. And I'll probably ask some questions along the way.
Sure. I studied mechanical engineering in college. I kind of fell into it. I've always I love cars. As a kid, I was super into space and rockets and trains. And people said, well, if you're into that kind of stuff, you should study mechanical engineering. Sure, I don't really know what that is, but it sounds great. I was very, I'm glad I studied mechanical engineering. Mechanical engineering teaches you how to solve problems. It teaches you design and manufacturing. Those are the two kind of basic flavors. And there's a lot of branches of mechanical engineering. Like aerospace engineering is a branch of mechanical engineering, and there's quite a few. My freshman and sophomore year, during the summer, I interned at Ford. So I was at world headquarters in Dearborn, and I had an amazing opportunity. This was actually my first introduction to innovation. Also, as I went out and there was a group there that had invented a new kind of air conditioning compressor. And here I am, this freshman. Man, I haven't even hardly taken any classes yet. And they paired me up with two MIT grad students, and they let us loose on redesigning the manufacturing system. And we were the first ones at Ford, and we wrote a paper about it that was able to do rapid manufacturing. So to get a new part to test, they used to have to sandcast, which would take weeks. And we took a CAD program where the machine tool would cut the part, and we'd send the instructions over the phone line to the machine in Connersville, Indiana, and get the part made in hours. And I was able to do that as a freshman, in college. And that taught me that innovation doesn't have to come from a specific place. Like you'd think that it would be some, very well seasoned engineer. But you'd think that for a variety of different reasons, I wasn't the person who should be involved in doing that. And it taught me a lot about innovation. I really appreciated that opportunity. But it also, mechanical engineering is really grounded in physical realities. Like the part's going to work or not. Like there's tensile strength, and there's stress and strain. There's so many things that, like, the thing will break. Like the thing will vibrate and make noise. Like there's just, the physical world is affects everything you do. And so you'll see later when I talk about how that affected my career in AI, it gives you a different perspective when you come from that kind of physical world. But I've spent almost my entire career in startups though. So I graduated from college, ended up getting an opportunity to work as a software engineer at IBM. And when I moved to the Bay Area, I was fascinated by the technology. I didn't know anything. I'm from Boston. I didn't know anything about San Francisco. It was like Rice-A-Roni and the Golden Gate Bridge. That's about all I knew. And uh, the Silicon Valley startup and technology scene, I got here right before the kind of the height of the internet boom in 1998, and I was fascinated. I was like, people are inventing things, every day. Every day you're riding on the train with someone who's inventing something amazing, and I really got into this kind of entrepreneurial thing. And so I've mostly had a career in startups. So Composabl is the eighth startup that I've worked for, but it all started with engineering.
I have to ask then, what has been a common thread or the common thread across these 8 startups?
That's a great. Oh yeah, it's a great question, but it's easy. They're all platforms. So
Okay.
I've never worked on a consumer product, like a software product that a consumer uses. They've all been B2B platforms that were very horizontal. I've never actually worked for a kind of solution platform either. It's always been horizontal, a platform that enables many users to do many different things in a kind of category or class of problems, which to me that's fascinating because my hypothesis is that platforms in novel high value technology areas require a methodology. Um, so what do I mean by that? Well, a great example of that is prompt engineering. Prompt engineering is a methodology for getting generative large language models to tell you, to produce something useful for you through natural language. That's a methodology. In some ways, like, Excel is a methodology. It's like a methodology for organizing data in what we now call a spreadsheet. But that was very, very novel. And so when databases were early and not everyone very, 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 very few people worked on databases at the beginning. But then, in order to get massive, widespread adoption, you have to have a platform that implements a methodology, and that's kind of what Excel is, or even before Excel, structured query language is. And so I became really fascinated with, regardless of the platform, my first 5 startups I worked for were platforms in ad and marketing technology. So regardless
Hmm.
of the type of platform, um, widespread adoption requires some sort of methodology. I became fascinated with that. And I was fascinated with the fact that a platform can produce almost an infinite amount of solutions. So if you give a platform to the right audience, they'll be able to produce, you know, exponentially more than any one company could ever produce in that area. That's kind of the theme of all the startups I've worked on.
I'm curious if this platforms requiring a methodology has something to do with this next question I'm going to ask. What led you then in this most recent venture to focus on artificial intelligence in the manufacturing industry
Yeah,
specifically?
and it's a bit full circle for me, and I've been doing this for the last 7 years. Composabl is only 2 years old, but it started at the last startup I worked at, which was actually not my startup, but that I participated in. It was a startup called Bonsai, and it was acquired by Microsoft, and then so at Microsoft, so really at 3 different companies, it was full circle for me. This idea that, okay, now there's AI that can do something. That means you could do something in the physical world. And I was like, now that's interesting. Because at the time, I don't know if you remember this, but in 2017, everyone was like obsessed with predictions. Like, just make a prediction, just make a prediction. They'll change everything. Just make a prediction. I'm like, oh gosh. And then when I realized, oh, there's AI that can actually, make these real decisions in the physical world, control systems. Well, I was fascinated. The third thing I was fascinated by was, well, if AI can learn, you should probably teach it something, right? Like if there's algorithms that can learn, well, you better teach it something. And that was honestly, that idea was not super well received when I first started working on it. There was this thought that you're going to restrict the AI, you're going to keep the AI from doing something amazing by teaching it. No, no. Nothing intelligent has ever been restricted by a good teacher, ever. That's a human being or a machine. And even if you look at things like very, very recent developments like DeepSeek, and there's a lot of controversy about DeepSeek, but if you read the paper and you see what they were doing, what they're doing is teaching. They're going, hey, let's draw boundary boxes around different areas instead of just letting it read the internet and kind of do learn whatever it's going to learn. Let's have let's teach it some specific things, and that's actually what a lot of what I've been doing over the past few years. But it's the idea of an AI-based control system controlling things in the physical world, AI that can do something, and teaching AI something. Those have been kind of my obsessions for the last 7 years.
Yeah, I like your comment that nothing intelligent has ever been restricted by a good teacher. Just from my research and my preparation, looking at AI, listening to some of your past podcasts and presentations, another thing that sticks out that I'm not sure every manufacturer grasps yet is one of the things that makes a particular industry, a particular vertical so ripe for artificial intelligence is when there's just a ton of data in that space as well. And that's one of the reasons that I'm hearing not just yourself, but other people are doubling down around artificial intelligence in manufacturing is because just the vast swaths of data that are there. Can you give us a little more context on the mass amounts of data that are just available to manufacturers right now and why it's an AI sweet spot?
It's super interesting you say it that way because um, there's two sides of it. There is vast amounts of data. It's funny. There was this wave of IoT. I'd say about 10 years ago, it started this wave of IoT and digital transformation that to me sometimes sounded like, hey, get out of the Stone Age by measuring everything in your factory. But then when I went around to a bunch of factories, people were like, what are you talking about? Like, we have this thing called a historian. It's a time series database that tracks everything that happens on these machines. Like, yeah, we might need to add new sensors or add some cameras, which is a totally legitimate point. But we've been measuring things for a really long time here. So there's a lot of data in what are called historians. There are these databases for factory information. Um, Juxtapose that though with the kind of data that's really hard to come by sitting in your human beings. And I call that expertise. So my favorite example of this is actually not from manufacturing, it's from chess. So back in 2016, there was an agent called Alpha Chess, and there was a companion agent called Alpha Go. And later there was one that played multiple games, but that learned to play chess and Go just by practicing against itself. And it beat many, many, many chess masters, and the AlphaGo version beat the best Go player in the world at the time, Lee Sedol. There's a whole movie about it. But what was interesting about chess is it discovered and used the 12 most common opening strategies in chess. At least one of those strategies is 1,000 years old. And so you go, oh my gosh, they spent millions of dollars of compute to have this thing practice and learn some stuff that we've known for a very, very, very long time. That's kind of how it is in factories. You can have an AI just look at your data, look at your data, look at your data, and discover a bunch of stuff that Susan and Joe over there could have told you in 15 minutes. And so there's this need to capture and codify high value subject matter expertise, frankly, before it goes extinct. I mean,
Yeah.
before it's gone forever. Some of it's very, very proprietary to and very valuable. It's core to the company's operation. Um, and you have to do that in the context of this vast amounts of data. So you're not just going to be able to look at the data like ChatGPT reads the internet. You're going to have to look at the data and interview the experts and then match those two things up together.
I'm going to give a little spoiler to one of the big lessons from this conversation today, which you've already started hinting at. And I think one of the most underutilized strategies around artificial intelligence right now for manufacturers is building up that database of expertise. As you said, the data that's sitting inside of the humans before, as we hear about all this time on this show, at trade shows, wherever you go, people are talking about how people are retiring, and we're going to lose a lot of that expertise in the manufacturing space. So, I know we need to start capturing that data and putting it to use before those folks walk out the door. I shouldn't call it data. We need to start capturing that expertise before those folks walk out the door.
Yes, and it will be amplified and explained uh, and fleshed out by the data that you have in the machines.
As we get into this conversation, I want to ask you about an example that I've heard you talk about multiple times over in terms of what is an AI agent and how does it really work. And we're going to tie it into, how to get get that database of skills built. You've talked about an example of an extruder for making Cheetos a lot. That was, I think, is just a perfect example for an AI agent application because of the variables that go into this piece of equipment to get that perfect poof and that perfect crunch inside of a Cheeto. So can you describe that? I've given folks a preview there, but what is this example and why is it such a sweet spot for an AI agent?
It's funny. I was just on a conversation with a company, major industrial company, and they were highlighting exactly what you're talking about. Because if you're not manufacturing things, it's hard for us to understand when we consume these products the difficulty in making them and how challenging it is. So we eat Cheetos, and my son loves Cheetos, and it's like, well, how hard could that be? And it was about 2018 when I got a call and I got explained. First of all, I didn't even know that Pepsi made Cheetos, but they make Cheetos and Doritos and Fritos and Funyuns and Lay's and all these snack foods. Okay, cool. And so what's so hard about making Cheetos? Well, first of all, Cheetos is made on an extruder. So what's an extruder? Remember those Play-Doh toys where you would put the dough in one side and then you'd pull a lever and then it would get pushed out in the shape of a star or a circle or a hexagon?
Yep.
That's an extruder. That's literally an extruder. So extruders are used to make soap, pet food, snack foods, films, sheets of plastic, all sorts of things. And so the cornmeal goes in to the extruder, and the extruder is basically a long metal tube with a screw inside. And extruders always heat up what's inside because you have to melt it. And in this case, you melt it, or in this case, cook it. So the cornmeal actually gets cooked in there, and then it gets forced out, always forced out a slit, just like the Play-Doh. And because the slit is small, there's pressure on one side and low pressure on the other side, and poof, it puffs up. And I said, well, that sounds difficult. And they said, yeah, it takes like 10 years to get good at things changing. Now, one of the things in manufacturing that not a lot of us think about is the composition of the input material is always changing.
Yeah.
The corn is different depending on whether it grew in Iowa or Illinois or wherever, whether the season was rainy there's lots of different things. The soil that will make the corn, different moisture, different fat, and you can't measure these things. So to all the digital transformation IoT folks that are like, oh, just measure everything, it'll work out. No. There's some things you're never going to be able to measure. And so it's actually expertise of practice. And this particular extruder had more than 25 knobs on it, more than 25 control variables that you change, and over 50 sensor variables that you're reading. That's a lot of information to measure in real time, to find out, and then to track the quality measurements. And every manufacturing operation has quality measurements. In this case, the Cheeto has to be within certain length criteria, certain diameter criteria, has certain curl criteria. Even the bubbles inside of it, the density, the bulk density of it needs to be within parameters. And so it took operators a very, very, very long time to practice with all those different situations, getting the things right, including the information that was frankly missing, like the moisture level of the corn. And so the first step in solving that problem was, yes, we did need to take data for sure. We took a bunch of machine data. But then I interviewed, things got really interesting. So let me tell you what happened first. First thing, we took a bunch of data, we created a simulation. Okay, why do you care about a simulation? Well, you don't want to, let's pretend you're in a steel mill. You don't want to make a bunch of bad steel and potentially hurt people by practicing on the real thing. So, and plus it would take forever practicing on the real thing. So you practice on a simulation. So you use data, or you use engineering equations to create a simulation. And then the agent gets to practice. Now the agent can practice on the cloud. The agent can practice playing a bunch of games at once. It's I don't know if you've ever seen people play 7 chess games at once, and they go boop, 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 and they play 7 opponents. You can do that in the cloud, right? So the AI can practice on 10 extruders at the same time. The computer doesn't care. So it's more practice in less time. And you don't want to just train on the data because it can memorize what to do in your specific situation. You want an infinite amount of representative data so that you can modify the situation of the scenario. Okay, cool. And we trained an AI that just learned by practicing, and we didn't really teach it much, and it was okay. It was just okay. Things got really, really interesting to a kind of expert level when we interviewed an operator, and the operator said, oh, did you know there's 5 different skills that are required? It's almost like a soccer team. On a team, and I think of these things as teams of agents, actually. Because on a soccer team, the goalie does something that is literally the opposite of what a striker does. The opposite. The goalie's 100% job is to keep people from scoring. The striker doesn't care about that at all. The striker's job is to score goals. So they're on the same team, but they have completely different roles. And that's how these skills work. And you use different skills at different times. So I used to call them skills, but now I call them skill agents. These things are individual agents that form a team to control this extruder. And when we did it that way, bam, expert control. Expert control.
Excellent example. And I'm going to try to do my quick over a beer play-by-play really quickly on some of my main takeaways from this. When we're talking about an extruder, one of the things that you mentioned is, hey, there are 25 knobs, 25 variables that, to an extent, that's the easy part of this process. But the hard part is the stuff that you really can't measure. In this case, the moisture and the corn composition, which, it just takes an experienced operator to look at that when it's coming out of the extruder to say, oh, based on what I'm seeing right here, we're going to adjust this because now I kind of have a feel for what
Yes.
this batch of corn, or more generally, this batch of raw materials was like. And
Yes. And that's the amazing thing about manufacturing is every process has that. It doesn't matter
yeah.
whether even mining, there's always a different composition. Like I was just talking to uh, a manufacturer of cheese this morning, and they were
Mm-hmm.
saying, actually, the consulting company was saying, in making cheese, the main ingredient is milk, and milk composition changes tremendously. It has wildly different amounts of fat depending on, a variety of things about the cow and what the cow is eating and all that, and of different amounts of sugar and different prices. Milk prices go up and down, and so the variation on the input is what really drives a lot of the um, improvement and optimization that people need are looking for in manufacturing.
And I like that you bring up this dairy example as well, because I want the manufacturers out there listening to this to be thinking of this in the context of their process. What are the things there that are variables that you really can't measure today? And I love your goalie striker example in the context of, hey, you're on a team, but these two folks on the same team are doing things polar opposite, completely different. And that's where these skills that you interview for come into play. So you build these, in this case, you said there are 5 skill agents, and that's what allows an AI agent to do what in the past was only able to be done by
100%.
your best operator in the
100%.
facility.
And I should say something too that I've done this a lot over the last 7 years. I mean, over 200 of these agents for Fortune 500 ish companies, and hardly anyone wants to replace anybody. What people want to do is they want to use these agents to train new operators and to help novice operators do better and to give expert operators either a second opinion or time back from things that were more mundane that now they can go do things that are more valuable.
I love that we're absolutely going to dive into this. Before we get there, I have to ask, where does this AI agent live? I just want to
Oh,
make
right.
sure that I want to make sure manufacturers aren't thinking this is like some orb that's sitting on top of the extruder that's like
Right, like beamed in from space and all that kind of stuff. No,
exactly.
it is literally a small piece of software that's deployed on your commodity Linux server, usually sitting under the desk in the control room, wired into it's all inside your edge infrastructure, um, in your kind of OT network, and wired to the machine through your kind of standard protocols that your controllers already use.
Yeah.
MQTT, OPC, OPC UA, and it's wired into each of the HMI, so the operator can see the recommendation at the same time as they see the sensor variables on the same screen that they currently do, or it can be wired into the DCS, so it can actually accomplish closed loop control.
So long story short, it is attached. You're saying it lives in this Linux server, but it is attached to be able to get the data and the variables you need from the various systems within inside of your facility, and you can also teach it those different skills as you learn that from your operators. Did I capture that correctly?
100%, yeah.
Excellent. Well, the main thing I want to get to then is something very important that you just mentioned, in that, not only does this allow an agent to, in some ways, have that knowledge that your best operator that might be retiring very soon has, it can also teach that next generation of operators that don't have that 10, 20 years of experience. Go into that a little bit more. How does we've talked about how the AI agent learns. Now, how does the AI agent teach?
Yes, that's really good. So, at the most basic level, you can use it this similar way to the way we use Google Maps or Apple Maps or Waze. Like, even in the Bay Area, I live in the San Francisco Bay Area. I'm learning new ways to navigate and which roads to travel at different times based on different traffic patterns that I didn't actually know. And so you're kind of following along, and this is how we learn and develop expertise. So when I first learned how to play poker, I read this. I don't know if you remember, because there was a big craze in the 2000s about playing Texas Hold'em poker, and I read this book by Doyle Bronson, and he basically said, "Here's the top 10 hands of poker, and here's how you practice. By if you get one of those top hands, play it, and if you don't, fold it." And I did that. I went to a game every week for about a year, and for the first like 6 weeks, that's how I played. I played exactly how he told me to play. Now, he didn't ever intend that that's the way I was always going to play poker. He was giving me he was walking me through a step-by-step process on how I could develop expertise and identify which hands I actually did want to play, and identify exceptions to the rules and which hands were not good to play, and how to. But he was doing it in kind of a lesson-based approach by saying, "Here, start simple and then practice." And when you get these kind of Google Maps or Waze instructions, then at first you're just doing what you're told because it'll lead to decent results. But soon you start developing your own expertise. And then you start, seeing exceptions, and you go, "Oh, that's interesting." And you maybe ask another operator, and then you start developing more expertise. The second way that it helps teach is it teaches in terms of the skills. So one of the things about alpha chess, even though it beat some of the best chess players in the world, was they said it had an alien playing style. They said it was like playing like against an alien, because it didn't obey the kind of the structure of strategy that us humans use. So it's not actually useful for learning how to play chess. What's useful for learning how to play chess is a system that has agents in it that actually do know the skills. And so, because what like a supervisor on a manufacturing line isn't monitoring every move that you make. It's not possible to monitor thousands of variables. What they're monitoring is, are you using the right strategy at the right time? And so if your multi-agent system has skill agents like strikers and goalies that have different schools of thought and different methods of playing and different strategies, then you can look at it and you can go, "Oh, I get it. This is when you run this kind of defensive play." I'm now switching to the American football analogy. This is when you run this kind of running play, this kind of passing play. This is when you run a reverse. And the expert can use that to supervise and train the younger folks, but the novices, the people that are gaining expertise, can also learn by watching the AI and what strategies it chooses.
Yeah. So basically you need to build an agent that follows, let's say, the best practices, the strategies that one can really learn from, versus some of these alien strategies that you described in the context of chess.
Yes, that knows, uses, and provides transparency into.
Okay. I follow that. Well, as we get to the end of this conversation, one thing I need to ask is, what is step one, maybe a step two, for manufacturers? Because we've talked about the importance of building a database of skills, and honestly, I hope manufacturers are listening to this realizing that artificial intelligence in these scenarios is a no-brainer, because we're literally talking about leveraging it to solve what many manufacturers would describe as their biggest issue, which is retaining the knowledge of their retiring workforce. And in my mind, I feel like building that database of skills right now, while you have those people for 2, 3, 5 more years, just makes a ton of sense.
Right.
But I don't want to answer the question for you. Can you share what would your recommended step be for manufacturers that want to take advantage of this?
It's a very astute question. I say one, I really highly recommend identifying your highest value skills that are most in danger of extinction. Now, if you have 50 operators that are, between 20 and 30 years old working on a specific process, that's not where you start your focus. You start your focus on the highest value skills that have the rarest expertise that is most likely to retire. You go, okay, that's where we start. Then you have to get your innovation strategy. So some larger companies have innovation departments or manufacturing R&D, and you say, you guys are going to be responsible for codifying these skills and building AI systems. Others, the operation owns, maybe smaller manufacturing operations that are still large but don't have a dedicated innovation group. You have to decide who's going to have the purview and time to do the innovation. I've worked with huge companies that said, our engineers don't have time to innovate, so we do stupid POCs because we don't have time to do anything material. So you have to figure out who's going to innovate. Then you have to give those folks not just the purview, but the tools. And I recommend you look for a platform, like look for something that's going to help you build these things yourselves. Because if you take a solution approach, there's too many use cases. I worked with one manufacturer that said, we have 1,000 use cases for intelligent agents. So you're not going to buy 1,000 different point solutions. So you need to look for a platform as leverage that's going to help you build in priority order the agents that learn to execute those high value skills.
So I like the way you described it. It's not just identifying all the skills, or it's the skills that are in danger of extinction, the folks that could potentially walk out the door tomorrow that are rarest, for example, like the ones that maybe there's a skill 5 people on the factory floor have versus a skill that 1 or 2 have. Start with the one that's 1 or 2, and then step 2 is working that in with your innovation strategy, and very much going back to an area you've been experienced in your entire career is, don't do 1,000 point solutions. Look for that platform that allows you to scale and build out those AI agents.
100%.
Which coincidentally is Composabl, but we don't need to. I figured we'd just say it out loud here at the end. But as my last question, I have to ask. We covered a lot of ground today. I really appreciate you breaking this down in a way that I think manufacturers can easily understand, and hopefully start thinking about AI beyond the context of machine learning or what you do in Copilot, for example.
Exactly.
So I think this was great. Is there anything else you'd want to leave the audience with, or something else you want to bring up before we wrap today's conversation?
The only last thing I'd say, and this is a really fun conversation, is you already have the expertise. Manufacturers, you have the expertise. Your operators have the expertise, and your engineers know the process. Empower your engineers to build intelligent systems. They designed and built everything we have anyway. And there's in technology this thought that industries need to be disrupted. Well, maybe not. What I actually think is that there's 100 million engineers out there in industry that if you empower them with the right tools, they'll innovate and engineer intelligent systems the same way as they have everything else.
Kence, I appreciate you taking the time to jump on Manufacturing Happy Hour today. I also appreciate all the things that I've learned through you over the past year. I'll definitely mention this in the intro, outro, but hey, if you're out there and you're looking for someone to follow on artificial intelligence and really pragmatic approaches for manufacturers, Kence is your guy. So, Kence, thanks so much for jumping on, and I will be seeing you around the industry very soon. I know that.
Thanks, Chris. Great conversation.
Cheers.